So again, for physics 2, we have an example here, but this example, interestingly, I can say it is going to test our knowledge that we received in the past analysis you've been making. And which analysis is that? The analysis, if we can make some flashback, we made derivations of some stuffs. We derived if light is moving from one media to another, media 1 to media 2, what is very true is that refractive index from moving in 1 to 2 is the same as 1 out of refractive index of 2 to 1. Or what we can say 1 to 2 times the 2 back to 1 is the same as 1. That is one thing we looked at. And then 2, if we can remind ourselves, because we are going now to build up on this, so you should be in position in remembering all these. We also said that if something moves from 1 to 2, this is for 2 media. These are for 2 media. Now if there are 3, 1 to 2, we have something like 1, 2, 3. Something comes here, and then moves out. We say that moving from 1 to 2 times 2 to 3 is the same as from 1 up to 3 direct. Is that okay? We also looked at that. And then lastly, we said that for any pair of media like this, we shall have any sin I being equal to constant. And that is what we are saying, that this is something to do with the Snell's law. And it is now one of the basic or the most important idea we shall actually try to use to analyze that. N equaling to sin I, that means that if I have N1, it would be sin I1 should be equal to N2 sin I2 and so on. So it will be a constant. So this is very, very important. So again, also what we should also not forget about is that we can also say N equaling to speed of light in what? Speed of light in vacuum over speed of light in a medium. So this is also important. So if you have looked at all this for the purpose of calculation, we are just good to go. So others, you can then remind yourself how to state the law, how to determine refractive index of a glass material, how do you explain refraction in terms of light, something of the kind. Just what you do smartly, follow us on our Tape Talk, on our Tape Talk website. You watch that and then we proceed with this. So, having known the procedures of dealing with this, let's now see how can we now solve this problem here. It's some simple problem that is giving us a stepping block to go to some other good one. So, how do we handle this problem here? They are telling us that we should calculate the refractive index of the glass if a ray of light is incident on it at an angle shown below, given that the refracting angle is 35. So they have given you R as 35.3 degrees. And don't forget, they're also telling you that what you also know that refractive index of air is always equal to 1. So what they need from us is the refractive index of the glass. Okay? And you should also know that we should have the angle of incident. But if you can remember, angle of incident is supposed to be this one here. Okay? So therefore, we cannot use 60. Please, you should understand such a tricks that they make for you. That if they give you 60 here, this 60 is not angle of incident. And remember, we are supposed to use angle of incident in our calculation. So that means that your I should be equaling to 90 minus 60. And that will give you 30 degrees. So the angle you should use should be instead 30, not the 60. So don't make a mistake and call angle I as 60. You'll go wrong. So, and now from there you can say using n sine I equaling to constant. Or you can say applying Snell's law. Okay? You can say applying Snell's law at O. Is that it? Yeah. So if you apply Snell's law at O, it would mean refractive index of air sine I equal to refractive index of glass sine what? Sine I. That is an alternative that we can actually talk about. So, as we have already said, the refractive index of air is 1. So, I'll say 1 times the sine of angle in air, and that one we said it should be 30, should be equaling to refractive index of glass, and is what is needed, times sine of angle in glass, and that is equivalent 35.3 degrees. We now have that. Okay? And then I can say sine 30 is equaling to energy sine 35.3 degrees. So here, because we want sine j, I divide both sides by sine 35.3 degrees. We have sine 35.3 degrees. This will go away, and the sine 30 out of sine 30 out of sine 35.3 is equaling to Ng. Therefore, Ng is equaling to, you can now pick your calculator smartly and say sine of 30 divided by sine 35.3, and that is 0.86. This is a very big value for refractive index. Sine 30 divided by sine 35.3. It is giving me 0.865. By calculation, yes, this is the answer, but practically refractive index of glass is smaller than this. But just because you have performed the calculation well and good, but practically refractive index of glass is just below that. And this is how actually we can calculate the refractive index of this material here as per this question here. So you can make one say, therefore, the refractive index of glass is 0.865 of this very glass here, following the condition they have given us in this question here. So let's meet in for more examples.